Welcome to the lesson on quadratic formula. Remember, you can turn in any missing assignments that you might have, and my office hours are Monday through Thursday from 10 to 11. You can always schedule a private office hour outside of that time by sending me an email. Very exciting news. So on Monday, I became an auntie. My sister had a baby girl, and her name is Frankie, and she is the cutest little thing I have ever seen. So I've been obsessed with trying to find baby clothes, baby toys, anything baby, and I'm gonna send all of the things to them. And I just really can't wait to meet her when all of this stuff is over and it's safe to go down there. And also, I definitely can't wait to teach her math. Like, that's gonna be the highlight of everything. So I would love to hear your celebrations, announcements, and struggles on your IP. Make sure you go ahead and go grab a piece of paper and a pencil or a pen and take some notes as you go through this video. Okay, pause on the practice problems because it helps to practice before you do the IP on your own. And if you're unhappy with any of your IP grades so far, whether it's from quarter 3 or e-learning, you can always resubmit them. Okay. Shout out to you all. You did not enter as many I don't knows or blanks on this last homework we did. So great job trying. I really appreciate that. And trying definitely gets you partial credit. So keep up the good work. All right, go ahead and pause and try these 4 problems from your bell work. These are review problems from earlier in the semester. Okay, so simplify without a calculator. The square root of 125. We have to create a tree for 125, and that breaks down into 5 times 25, and 25 can be broken down into 5 times 5. We don't need to break down 5 any further because the only factor is 1 in itself. So that means it's a prime number. And so 5 and 5 and 5 are the prime numbers of 125. So we can go back in our problem and replace 125 with 5 times 5 times 5. Now we have to circle the pairs. So there's one pair of 5s and then one single 5. The pair of 5s comes out as 1 5. So we'll have 1 5 on the outside, and the 5 that did not have a pair would just stay under the radical. Okay. Number 2, simplify without a calculator, the square root of 28. We can make a factor tree for 28, and this breaks down into several options, but I chose 2 and 14, which breaks down into 2 and 7. Okay. We've gotten it down to our prime numbers here, so that's what we can replace 28 with here. So we'll have 2 times 2 times 7. We should go through and circle our pairs. Well, there's only one pair of 2s, and then there's 1 7. So the pair of 2s comes out as 1 2, and that 7 will stay underneath the radical by itself. And that's your answer. Number 3, estimate with a calculator, round to the nearest tenth. So we have the square root of 30. When we put that in our calculator, we'll get 5.477 and some other numbers. And we need a round to the nearest tenth, so that'll be 5.5. Number 4, if we estimate the square root of 77 with a calculator, we'll get 8.7749 and some other numbers. And rounded to the nearest tenth gives us 8.8. Good job. So let's get started with our lesson for today. It's called the quadratic formula. By the end of the lesson, you will be able to solve quadratic equations using the quadratic formula. If you do not know how to solve quadratics by factoring, which we learned last week, please go back to haiku and complete those lessons. Let's start with finding the zeros. So when we solve a quadratic equation like ax squared plus bx plus c equals 0, we are finding the x-intercepts, or the zeros of the parabola y equals ax squared plus bx plus c. The number of zeros that we find gives us information about the parabola. So for example, if I have 2 real zeros, so if I have 2 x values in my final answer, what that means is that the parabola is crossing the x-axis at 2 places. So here's my y-axis and here's my x-axis. So here, my parabola is crossing the x-axis at 2 places, And so is it in the second example, 1 and 2. So when we have two solutions, we have two real zeros, which means our quadratic is crossing that x-axis at 2 points. If we have one real zero, so we have one x value as our solution, that means that our parabola only touches our x-axis at 1 point. And same for the second example here. So in this case, we have one real zero. The last case that we have is no real zeros. So there are no zeros that satisfy the quadratic. In this case, that means that our parabola doesn't touch our x-axis at all. So that blue parabola ends right here. It never really makes it down to that x-axis, so there's no real zeros. Same for this example over here. So this is our x-axis, and our parabola ends at that very tip of blue. So that means that we have no real zeros because our parabola never touches that x-axis. How about you give it a try? Go ahead and pause the video now and identify how many zeros each parabola has. So in this case, it touches the x-axis once, so there's one solution. In this case, my x-axis is here and my parabola doesn't ever touch it, so there are 0 zeros. And here, my parabola touches the x-axis twice, so there are 2 zeros here. Okay, so let's go ahead and try and find the zeros by factoring, okay? So we've already learned how to do this. So what we do first is put our equation in standard form. So it will be x squared minus 3x plus 1 equals 0, okay? Now we need to factor. So I need to identify A as 1, B as -3, and C as 1. So I need to find two numbers that multiply to A times C, which is 1 times 1, which is 1, and adds to B, which is -3. Okay, well, our factors for 1 are 1 times 1 and -1 times -1. Well, if I multiply 1 times 1, I do get 1, but when I add those, I get 2. So that doesn't help. When I add -1 plus -1, I get -2, which is not -3, so that doesn't work. So there are no magic numbers here. What would they be? Well, we can't find out using factoring, okay? So what we have to do is find another method that we can use to find the zeros of our equation, okay? That other method is going to be what's called the quadratic formula. So when a quadratic equation cannot be factored, we use the quadratic formula to find the zeros, okay? So to solve a quadratic equation using the quadratic formula, there are 3 steps. So step 1 is the equation must be in standard form. So standard form of the equation is the same as with factoring. So it's ax squared plus bx plus c equals 0. Okay. Then we had to identify a, b, and c. And the last thing we do is plug our a, b, and c values into the quadratic formula. Okay, so our quadratic formula is x equals -b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so once we look at our quadratic and find out what a, b, and c are, we're going to plug those values into the quadratic formula and solve. Okay, so let's solve using the quadratic formula. So we have find the zeros of y equals x squared minus 3x plus 1. This is the same exact quadratic that I just tried to solve by factoring, and I couldn't find the magic numbers. But I'm going to show you that we can actually solve it if we use this other method called the quadratic formula. So this equation in standard form is going to be x squared minus 3x plus 1 equals 0. Okay, A is going to be the value in front of x squared. Well, there's not one there, so we assume that it's 1. So A is 1. B is going to be the value in front of x. So B is -3. And C is that last constant. So C is 1. Okay, so we've done step 1, step 2. Now let's do step 3. Let's use the quadratic formula to solve. Okay, so I put the quadratic formula up here in the top right corner so that we can reference it. So it tells us that we should have x equals negative, then our b value comes in, plus or minus the square root of b squared. So we're going to plug in b there, and we're going to square it, minus 4 times a times c, all over 2a. So let's go ahead and plug in our values of a, b, and c. So b is negative 3. Then it says b squared, so we'll plug in a negative 3 here. 4 times a is 1. C is also 1. And then all over 2 times a, well, a is 1. Okay. Now that we have those things plugged in, we can go ahead and simplify our numerator first. So negative 3 times a negative 3 gives us a positive 3. Then we have the plus or minus symbol. And we have 9, because negative 3 squared is 9, minus 4. So our numerator is done. Over 2 times 1, which is 2. So now we simplify this even further. 3 plus or minus the square root of 5 all over 2. Okay. So now we need to simplify. First, let's figure out what the square root of 5 is equal to. And we can figure that out by using our calculator. So if we plug in the square root of 5, we would get about 2.3. Okay. So what we're going to do is we're going to write this equation, and we're going to replace square root of 5 with 2.3. Okay. So now we have to create our two equations that we need. Well, where are our two equations going to come from? What we need to do is honor this plus or minus symbol. Okay. So from this equation here, we're going to set up two equations. Okay. Our first equation is going to be 3 plus 2.3 divided by 2. And our second equation is going to be 3 minus 2.3 divided by 2. Okay. And our answers to both of these separate equations are going to be our zeros. So this first one is 2.65. And this one here is 0.35. Okay, so the zeros of the quadratic y equals x squared minus 3x plus 1 is 2.65 and 0.35. Okay, let's solve using the quadratic formula. So find the zeros of y equals x squared minus 5x minus 7. First thing we need to do is write it in standard form. So we'll have x squared minus 5x minus 7 equals 0. Now we identify A. A is 1, B is negative 5, and C is negative 7. Okay. Now we can plug those values into our quadratic formula. So we'll have x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. I can go ahead and plug in those numbers. So we'll have negative b is negative 5, b is negative 5, a is 1, c is negative 7, and a is 1. Okay, so now we can simplify this, and we'll get 5 plus or minus the square root of 25 plus 28 all over 2. Okay, so this equals 5 plus or minus the square root of 53 all over 2. And then we have our two separate equations. We're going to have 5 plus the square root of 53 over 2. And we're going to have 5 minus the square root of 53 over 2. When we solve these, we'll get our zeros, okay? So the square root of 53 is what we have to put in our calculator before we can add it to 5, okay? So when you simplify this first one, you're going to get negative 1 point, you're going to get 6.2. And our other zero is going to be negative 1.2. Okay, so we found our two zeros to the quadratic y equals x squared minus 5x minus 7. And it's 6.2 and negative 1.2. All right, go ahead and try example 2 and come back when you're done. Okay, so standard form would be x squared minus 4x minus 5 equals 0. We'll have 1, negative 4, and negative 5. And then we can go ahead and plug them into the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2 times a. So when we plug those numbers in, we'll get negative 4. Negative 4 goes here. Then we have 4 times a is 1, c is negative 5. Over a, and a is 1. So this simplifies to 4 plus or minus the square root of 16 plus 20. All over 2. Okay, so this equals 4 plus or minus the square root of 36 divided by 2. Turns out that the square root of 36 is a perfect square, so that is equal to 6. So we can write out our two equations to solve. Our first equation would be 4 plus 6 over 2. And then our second would be 4 minus 6 over 2. So our first 0 is going to be 5. 4 plus 6 is 10, divided by 2 is 5. And then 4 minus 6 is negative 2, divided by 2 is negative 1. So the zeros to this quadratic is 5 and negative 1. Okay, solve using the quadratic formula. We have y equals 25x squared minus 10x plus 1. First step, write our quadratic in standard form. So we'll have 25x squared minus 10x plus 1 equals 0. A is 25, b is negative 10, and c is 1. Let's go ahead and plug it into our quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So we'll have b is negative 10, negative 10, a is 25, c is 1, and a is 25. Okay, so this simplifies to negative times a negative 10, positive 10, plus or minus the square root of 100 minus 100 all over 50. And that simplifies to 10 plus or minus the square root of 0 all over 50. Okay, the square root of 0 is simply equal to 0. So when we make our two equations, we're going to have 10 plus 0 over 50 and 10 minus 0 over 50. So this is going to be equal to 1/5, and so is this one. Okay, so when we have the same number, that means we just have one solution. Okay, so the only answer to this would be 1/5. Okay, so go ahead and try number 4. You should get one solution. You'll have two of the same answers, so that answer would just be one of those numbers. Okay, so in standard form, we have 4x squared plus 12x plus 9. And that is equal to 0. It will be 4, 12, and 9. Now, we'll plug it into our quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So we'll have 12, a is 4, c is 9, and a is 4. So this simplifies to negative 12 plus or minus the square root of 144 minus 144. All over 2a, which is 8. So we'll get negative 12 plus or minus the square root of 0 all over 8. Again, the square root of 0 is equal to 0. Uh-oh, dropped my pen. So we'll have two equations now. We'll have negative 12 plus 0 over 8 and negative 12 minus 0 over 8. We'll get the same answer for both. So we'll get negative 3 over 2 and negative 3 over 2. So our 0 for this equation is just one solution of 3 over 2. Good job. Okay, so solve using the quadratic formula. First step is that we need to get our quadratic into standard form. So we need to add 1 to both sides. So our quadratic would be 2x squared minus 2x plus 1 equals 0. A is 2, b is negative 2, and c is 1. So our quadratic formula would be negative b plus or minus the square root of b squared minus 4ac all over 2a. B is negative 2, 4 times A is 2, C is 1, and A is 2. So this simplifies to give us 2 plus or minus the square root of 4 minus 8 divided by 4. And this equals 2 plus or minus the square root of negative 4 over 4. So there's a problem here. Because we have a negative under our square root, we can't create two solutions. We can't go any further. The only answer here is that we have no real zeros. Okay, so whenever you get to a point and you see that your square root has a negative sign underneath, there are no real zeros, and that's your answer. Okay, go ahead and pause and try example 6. Okay, so we need to add 6 to both sides in this case. So standard form would be 3x squared minus 3x plus 6 equals 0. A is 3, B is negative 3, and C is 6. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2 times a. So b is negative 3, negative 3, 4 times A is 3, C is 6, and A is 3. So this equals a 3 plus or minus the square root of 9 minus 72 over 6, which equals 3 plus or minus the square root of negative 63 all over 6. All right, we have a problem here. There is a negative under the square root, so we can't go any further. So our answer for this one is no real zeros. Okay, let us go ahead and skip that one in the interest of time. And we are going to go ahead and do our last problem. And this is the applications of quadratic formula. So a ball is thrown straight up from 3 meters above the ground with a velocity of 14 meters per second. The height of the ball can be modeled by the equation h equals 3 plus 14t minus 5 squared. How long will it take for the ball to hit the ground? First things first is we need to write this in standard form. So that'll be negative 5t squared plus 14t plus 3 equals 0. We have to identify A, B, and C. So A is negative 5, B is 14, and C is 3. Now we can go ahead and plug these values into the quadratic formula. So we'll have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so b is 14. B is 14 here, minus 4a, negative 5 goes here, c is 3 over 2 times negative 5. Okay, so we have negative 14 plus or minus the square root of 196 plus 60 all over negative 10. And this simplifies to negative 14 plus or minus the square root of 256 all over negative 10. Okay. Which equals negative 14 plus or minus the square root of 256 is 16 all over negative 10. Okay, so now we have two equations that we can set up. The first one is going to be negative 14 plus 16 divided by negative 10. And the second one is going to be negative 14 minus 16 divided by negative 10. So our two solutions are going to be negative 1 over 5 seconds or 35 seconds. Well, we can't have negative time, so that means our only solution to this word problem is going to be t equals 35 seconds. Great job today. Please go to Haiku and find the link for the Quadratic Formula IP. Use this video, your notes, and office hours to complete the IP. Email me if you have any questions at all. The code word for today is niece. Have a great day.